വെൽക്കം ഓൾ. സ്റ്റീരിയോ ഐസോമറിസത്തിലെ 5ാമത്തെ ലെക്ചറാണ് ഇന്നത്തെ നിങ്ങൾ കാണുന്ന ഈ വീഡിയോ. ഇതിന് മുമ്പത്തെ ലെക്ചർ ഒന്നുകൂടെ ശ്രദ്ധിച്ച് കേട്ടതിന് ശേഷം ഇതിലേക്ക് കടക്കുക. ആരുടെങ്കിലും മിസ്സായിട്ടുണ്ടെങ്കിൽ നിർബന്ധമായി കണ്ടതിന് ശേഷം മാത്രം ഈ ലെക്ചർ കാണേണ്ടതാണ്. ഒരു കണ്ടിന്യൂഷനാണ്. അപ്പോൾ ഒരു കണ്ടിന്യൂഷൻ കിട്ടണമെങ്കിൽ നിങ്ങൾ പ്രീവിയസ് ലെക്ചർ കേട്ടതിന് ശേഷം ഇതിലേക്ക് കടക്കുക. Specific rotation, or in bracket alpha, it is a property of chiral compound. It is defined as the change in the orientation of monochromatic plane polarized light per unit distance concentration product as light passes through a sample of compound in a solution. Or it is the observed degree of rotation divided by L into C. L is the length of the tube in decimeter and C is the concentration in gram per ml. Okay. Or this is also represented at particular temperature T, or each temperature will have different specific rotation. That is why temperature of the experiment and lambda. It is normally polarimeter use sodium lamp, wavelength around 589 nanometer. So plane polarized light, when it is passed through optically active solution, plane of polarization may be changed to either right or left direction. In the right direction it is called dextrorotatory, in the left direction it is called levorotatory. So isomers which rotate plane polarized light left directions are called levorotatory. Isomer which rotate plane polarized light in the right directions are called dextrorotatory. So this is a polarimeter. Now enantiomers. I hope you remember this picture. I have used it many times in the previous lecture. So what happened? These molecules contain different orientation of red and white atom. So they are mirror images to each other. That is, its mirror will be like this and this mirror will be like this. So they are mirror images to each other. So enantiomers are the molecules of mirror images to each other. So enantiomers are chiral molecules that are mirror images to each other. They are non-superimposable on one another. So I have demonstrated you clearly in the last class how a non-superimposable on one another work with the demonstration. So this means that molecules cannot placed on one top of another and give the same molecule. Chiral molecules with one or more stereocenters can be enantiomers. So if only one chiral center, the molecules must be enantiomers. If molecules contain more than one chiral centers, chiral carbon, they may or may not be if molecules contain more than one chiral center, chiral carbon, they may or may not be enantiomers. So only one chiral carbon, it should be considered they are always enantiomers. I will explain you how if more than one chiral carbon present in a molecules become not enantiomers. This is one example for enantiomers. So here you see COH and OH in one plane, but CH3 and H are in different plane, so they are enantiomers. This is another example. Cl and Br, Cl and Br, C in a one plane, and H and F are in the opposite. H here it is F and here it is H, so they are in the opposite plane. Another example you see here, CH3CH, they are in the one plane, CH3CH3, but OH and CH2CH3 are in the opposite plane, so they are enantiomers. Now diastereomers. They are not simply they are enantiomer, they are isomers, but not mirror images to one another. So non-superimposable on one another. Stereoisomers with two or more stereocenters can be diastereomers. So I told you, if there are only one chiral carbon, that will be always enantiomers. If there are more than one chiral carbon, they may be enantiomers or diastereomers or anything else. But here you can say that the stereoisomers with two or more stereocenters can be diastereomers. Diastereomers are possible when molecules contain more than one chiral carbon. So you see here, these molecules contain two chiral carbon. Okay, all contain two chiral. They are isomers. They are two chiral carbon. One chiral carbon, CH3CH. This is another. So this is one chiral carbon. This is another chiral carbon. This is another one carbon. So these A and B are mirror images to each other. So they are enantiomers. And C and D are, you see here, OH this direction, OH this CH3 in one plane, and OH and B are in the opposite plane. So OH this side and H this side. So these C and D are enantiomers. A and C are diastereomers. They are not mirror images to each other. Similarly, A and D are diastereomers because they are not mirror images to each other. B and C are diastereomers. They are not enantiomers. B and D are diastereomers. So I hope you got what you mean by diastereomers. Another example you take, 1 and 2 are diastereomers because they are not mirror images to each other. 1 and 3 are enantiomers, okay, or mirror images to each other. But 1 and 4 are see 1 and 4 and 1 and see they are 1 and 3 are same actually. These molecules is just rotated. Okay, so molecule is just rotated. Okay, simply you can say that 1 and 2 are diastereomers. Okay, or 1 and 4 are diastereomers. 3 and 2 are diastereomers. 3 and 4 are diastereomers. Now difference between enantiomers and diastereomers. I have charted main point here. You just note down the things. Enantiomers are stereoisomers that are non-superimposable mirror images to each other. Diastereomers are stereoisomers that are not mirror images to one another. പറഞ്ഞ കാര്യങ്ങൾ തന്നെ ഒന്ന് ജസ്റ്റ്. They are optically active. They may or may not optically active. They show equal but opposite specific rotation. Optical active diastereomers show different specific rotation. Optically active diastereomers shows different specific rotation. Here they may be different but opposite direction. Here they shows different specific rotation. Value itself will be different. They may not be same and opposite like enantiomers. Enantiomers have same physical property in the achiral medium. What do you mean by achiral medium? So your medium is not optically active. So water is an achiral medium. But as a biological student, in the enzyme condition or they have different that is called the achiral and chiral medium. So if your medium enzyme is a chiral object, chiral molecules, they are highly specific action to specific chiral molecules only. They, for example, you can eat D-glucose but you cannot eat L-glucose. That could not digest by enzymes. Okay, so that's why that is what if the system itself is, or a solution, if the medium is achiral, the enantiomers shows same physical property. Diastereomers show different physical property in chiral and achiral medium. They have different physical property. They have different melting point. They have different boiling point. But the chiral enantiomers will show same melting point, etc. Okay, so they have they only shows different physical property in the achiral medium only. Chiral medium only. Achiral medium they have same physical property. They have same chemical property in achiral medium. They have same chemical property also with the achiral reactant. They show different chemical property. The diastereomers shows different chemical properties. Equimolar mixture of enantiomers are optically inactive. Equimolar mixture L D isomer and L isomers, you take equal mixture, equal concentration, mix with each other, and they will be optically inactive. Such mixture are called racemic mixture. We'll discuss later. So equimolar mixture of the enantiomers are optically inactive. But equimolar mixture of diastereomers, optically active diastereomers. I told you diastereomers may be optically active or optically inactive. Okay, optically active diastereomers are equimolar mixture of the optically active diastereomers are optically active. Equimolar mixture of diastereomers that are optically active will be optically active. But here equimolar mixture of enantiomers are optically inactive. Optically inactive എന്ന് പറഞ്ഞാൽ പ്ലെയിൻ പോളറൈസ് ലൈറ്റിൽ ഒരു ഡീവിയേഷനും കാണിക്കില്ല എന്നർത്ഥം. അതായത് ഈക്വൽ കോൺസെൻട്രേഷൻ ആയതുകൊണ്ട് വണ്ണ് ലെഫ്റ്റിലേക്കും അനദർ റൈറ്റിലേക്കും, രണ്ടും ലെഫ്റ്റും റൈറ്റും ക്യാൻസൽ ആയിട്ട് they are like that. Okay, so this is all about this. I told you this is enantiomers examples.